Okay, in this video we are going to look at what's called compositions of trig functions. So if you think back to algebra, the composition of a function meant you take one function and insert it into another and then solve your new problem. Well, we're going to do a similar idea when we are working with trig functions, in that we've insert one into the other. The idea is you have to work from the inside out. So you have to do everything inside your parentheses first, as well as you need to make sure that you are using the correct range as dictated by your problem. So the first thing that we have here is we have the inverse sine of this stuff. So we got to evaluate this stuff first. So we want the sine of 2 pi over 3. So that's what we are looking at. We are looking specifically at the sine of 2 pi over 3. So one of the things that we can do is we can refer to a unit circle. So a unit circle would look something like this. And one of the things that you should notice about this circle is that not only do we have the degrees here in the middle, we've got our radian measures on the outside, but then we've got our coordinate point measures. And these coordinate point measures would help you if you were to draw your circle or your triangle. So if you look here, say at our 30-degree example, you can visualize dropping your triangle straight down, and then your triangle would show up right here. And you could see it right like that. So what these two coordinate points are telling you is this is telling you the x measure and the y measure for this particular triangle. So at a 30-degree triangle, my x here would be square root to 3 over 2. My y would be 1/2, which makes my hypotenuse side here 1. That's why it's a unit circle. And you can draw that same triangle or see it no matter what we do. If you look, here's my 45. Drop that straight line down, and right here would be your triangle. See, it drops straight down, and there it is. And so your coordinate measures again are telling you x and y. So how does that help? Well, I want the sine of 2 pi over 3. So if you notice, 2 pi over 3 is right here. It's at my 120 degree. So I would drop, I'm going to use my ruler here so you can see. I would drop my straight line right down here. Okay, so if you notice, you can see that my triangle is going to go straight up the 120 line, drop straight down, and then come over. So here would be my triangle, is what I'm looking at, is right here. Okay, so I've got my x measure, so that would be this piece here, is -1/2, which makes sense. And then I've got my y measure right here, which is the square root of 3 over 2. Now how does that help? Well, it helps because I want sine, and sine is opposite over hypotenuse. My hypotenuse is 1. So the sine of 2 pi over 3 is going to be this value right here, which is the y value of my coordinate point, or square root of 3 over 2. Okay. So here, how does that help? Well, this says my sine of 2 pi over 3 we actually find to be the square root of 3 over 2. Why? Because it is the y value off the unit circle. So that being the case, what that says now is that I have done inside the parentheses. So I now have the sine inverse of the square root of 3 over 2. Now, first of all, the inverse sine has a very specific range. So when we're talking about inverse, again, here's my unit circle. The inverse sine is looking purely at -pi over 2 up to pi over 2. So we are looking at just this half of my circle. Okay. Now I want to have the inverse sine of the square root of 3 over 2. So I know that sine is going to be opposite over hypotenuse, which means I'm looking in this range here. specifically for where I have a y value that is positive square roots of 3 over 2. Okay? So let's cover up the part of the unit circle that we don't care about. So we don't care about any of that. We are just looking at this piece right here. And I am looking in my coordinate points here for which coordinate point has a y value that is the square root of 3 over 2. And so if you notice right here, at my 60-degree line, I have y value is positive square roots of 3 over 2. Therefore, when we look at it, it would be this degree measure of this line that we care about, and that's 60 degrees, or pi over 3. So when I take a look here, we end up with 60 degrees, or pi over 3, and that is using the unit circle. Okay. Now, I could go ahead and check my work. Using my graphing calculator. So here's a calculator. Okay. And I want to go ahead and I want to check it. I want to see if my logic with my unit circle actually works. So I want to do the inverse sine. So first I'm going to make sure that I'm in degree mode. So right here it should be degrees, and it is. So I can quit out of that. So I want to go second sine, which pulls up my inverse. And I want square root of 3 over 2. So notice above my x squared right here is a square root button. So I'm going to go second x squared, opens that root, 3. And then I need to divide by 2, close it, hit enter. Notice I come up with 60 degrees. So what you've just seen is how you can use a unit circle and do it by hand, and then be able to check your work using a graphing calculator. Alright, so let's look at another one. So here I want to do the cosine of the inverse sine of square root 3 over 2. Well, the cool thing is I've already done inside here. I did it in this problem. So automatically I know that my inverse sine of the square root of 3 over 2 is going to give me 60 degrees. Which means I am doing the cosine of 60 degrees. Now I can use, again, my unit circle to do it by hand, because let's face it, sometimes your calculator doesn't work. And cosine is your x value. So again, I'm looking at 60 degrees, so my 60 degrees is right here. Cosine is adjacent over hypotenuse, so adjacent would be this x value line. So I'm looking at the x coordinate, which is just 1/2. So here we would end up having that the cosine of 60 degrees is going to equal 1/2. Again, you can check that with your calculator to be sure that you got the right measure. Now, what happens if I give you a measure that does not appear on your unit circle? So I want the cosine of the inverse tangent of square root 3 over 4. So if you look at your unit circle here, one of the things that you're going to notice is that nowhere do I have the square root of 3 over 4. Okay, it just doesn't exist. So what that tells you is that your angle is not one of these special angles that we have here. So how would we go about attacking this one? Well, you can't just plug it into your calculator because you want to have the exact value. So you have to draw your triangle. So we're going to start with our coordinate plane here. And one of the things that we know is we know that we're looking at inverse tangent. So the inverse tangent is dealing with the positive to negative pi over 2. So we're dealing just with this side. Okay. And notice both of my values here are positive, so we're going to be up here in this first quadrant. So I can go ahead and draw in my triangle here, because we're going to be here in this first quadrant. So this is going to be my angle. And then we know tangent is always opposite over adjacent. So this is going to be the square root of 3 over 4. And what we don't know is what your radius is. So this would be your radius. So the first thing we have to do is find the radius. So here again we've got a squared plus b squared equals c squared. Plug in what you know. 4 squared plus the square root of 3 squared is equal to my radius squared. 4 squared is 16 plus 3 equals my radius squared. So here we're going to have the square root of 19 is equal to my radius. Now that you know that, we can go ahead and find the cosine. Okay, so remember your cosine of an angle is going to be adjacent over hypotenuse. So here we are looking at your cosine is going to be 4 over the square root of 19. So we need to rationalize here, so we're going to end up with 4 square roots of 19 all over 19. And this is going to be what we were looking for. Now the last one we have is the inverse sine of the tangent of negative pi over 4. So when we're looking at negative pi over 4, we are looking at the fact that pi over 4 is our 45, 45, 90 triangle. So to verify that, you can look right here at your unit circle. So pi over 4 is this 45-degree angle. So even at negative pi over 4, we're still looking at the 45-degree angle. And so here what you would notice is that my x and my y value are going to be exactly the same. So when you have square root 2 over 2 divided by square root 2 over 2, you get 1 as a result. So here, this is going to end up being the sine inverse of negative 1. And so here, again, we have to remember when we're talking about the inverse sine, we are talking about negative pi over 2 up to pi over 2 in terms of the range. And so in this case, if we were to evaluate at negative 1, remember sine, we're usually looking at the y value. So here, if we come into this, we are looking for this side of my unit circle, and I am looking for where I have a y value at negative 1. And so here would be my negative 1 y value. And so what do we know about this? We know this is negative pi over 2. And so here we would end up having that my inverse sine of negative 1 is negative pi over 2. And there you have it, a snapshot on what it means to work with compositions of trig functions and using their inverses. So if you have any questions, please be sure to let me know. Otherwise, just remember, utilize that unit circle as often as you can and try to do as many things by hand as you can. Using your graphic calculator only as a check yourself when needed. Otherwise, I hope you had as much fun as I did, and I'll see you next time.